Hello and welcome to this video from Heybridge High School Maths Department. In this video we'll look at multiple strategies for solving probability problems. So here's our first question, and we've got a bag that contains counters that are red, blue, green or yellow, and we've got a table that tells us how many red counters there are, and then it gives us expressions in terms of x for the number of blue, green and yellow counters in the bag. And we're told that the probability it is red is 9 out of 100. So that means that altogether there must be 100 counters in the bag. And we've got to work out the probability that it's green. So first of all, we need to form an equation in x. So we're going to add together the number of counters for red, blue, green and yellow. And we know from the probability that we were given for red that that's equal to 100. Now let's simplify the left hand side. So let's collect our x's. So we've got 3x plus 2x. That will give us 6x. And then we've got 9 take away 5, which will give us 4. And that will be equal to 100. Now let's subtract 4 from both sides to give us 6x equals 96, and then let's divide both sides by 6, and that will give us x is equal to 16. Now we can work out how many green counters we have in the bag by substituting x equals 16 into the expression that tells us the number of green counters. So green is equal to x take away 5. That will be equal to 16 take away 5. So that's equal to 11. So there are 11 green counters in the bag, and altogether there are 100 green counters in the bag. So the probability of picking a green counter will be 11 out of 100. Question 2. Two different schools, School A and School B, attended a conference. 12% of the attendees were teachers and the rest were students. 47% of the attendees were from School A. 48% of the attendees were students from School B. One of the attendees is selected at random. Find the probability that they are a teacher from School A. So I'm going to draw a two-way table. So we'll have School A here, School B here, and then we'll have our total here. And then let's have teachers along the top and students there, and then let's have another total here. Now, because we're talking about percentages, these as fractions would be 12 out of every 100 of the attendees were teachers, 47 out of every 100 of the attendees were from School A. So in order to work out probabilities, we can just use percentages as the numerical values in the table. So we know that 12% of the attendees were teachers, so let's pop those in there. 47% were from School A. We know that our totals have to add up to 100%, so we can work out how many altogether were from School B by doing 100 take away 47. So that will give us 53%. And then we can do the same to work out how many altogether were students. So we've got 100% take away 12, and that will give us 88. 48% of the attendees were students from School B. So that means that we can work out how many were students from School A. And that will be 88 take away 48. That will give us 40. Now teachers, we're interested in teachers from school A. So we know that altogether 47% were from school A, and we know that 40% are students. So 47 take away 40 will give us 7. That's actually as far as we need to go with our table. So the probability that we have a teacher from school A will be 7 out of 100, which we can write as 7%. Shown is a spinner. The probability of a 1 is 2x, the probability of a 2 is x, and the probability of a 3 is 2x. Calculate the value of x. So we know that probabilities always have to sum to 1. So if we add together these three expressions for our probabilities of spinning 1, 2 and 3, we can put those as equal to 1. Now we need to simplify the left-hand side, and that will give us 5x equals 1. Then if we divide both sides by 5, x will equal 0.2. We can then work out the probability of spinning each number on the spinner. So the probability of spinning a 1 will be, it's 2x, so that will be 2 times 0.2, which will give us 0.4. The probability of spinning a 2 is just x, so that will just be 0.2. And the probability of spinning a 3 is 2x, which will be the same as the probability of spinning a 1, so that will also give 0.4. Now, we move on to a tree diagram. So the spinner is spun twice and the scores are added together. Work out the probability of the final score being 4. You may use the tree diagram to help you. So let's fill in the probabilities on the branches. So the probability of spinning a 3 is 0.4. The probability of spinning a 2 is 0.2. And of spinning a 1 is also 0.4. Now you can see that the probabilities don't change on the second spin. And that's because these events are independent. So if I spin a 3 on the first spin, that does not affect the probability of me spinning a 3 on my second spin. Now, I'm interested in the final score being 4. So how could I get 4? Well, if I spin a 3 on the first spin, I'd need to spin a 1 on the second spin to get a 4. I'm going to use the AND rule. I need 3 and 1. So I'm going to do the probability of spinning a 3 multiplied by the probability of spinning a 1. That's going to give me 0.4 times 0.4, which will give me 0.16. Now, if I spin a 2 on the first spin, I'm going to need to also spin a 2 on the second spin. So I'm going to do the probability of a 2 multiplied by the probability of a 2, and that will give me 0.2 times 0.2, which will give me 0.04. And then finally, if I spin a 1 on the first spin, to get 4, I will need to spin a 3 on the second spin. So I'm going to multiply the probability of spinning a 1 by the probability of spinning a 3, which will be 0.4 times 0.4, which will give me 0.16. Now I've used the AND rule to calculate these three probabilities. I'm now going to use the OR rule to work out the probability of the final score being a 4, because I can get 4 in any one of these three ways. So I can get it by spinning a 3 and then a 1, or by spinning a 2 and then a 2, or by spinning a 1 and then a 3. So when I'm doing the OR rule, I'm going to add. So the probability of the final score being a 4 is going to be 0.16 plus 0.04 plus 0.16, and that will give me 0.04. 0.36. Now we have another tree diagram. George has a bag of marbles and there are 6 red and 4 white marbles. George takes out a marble at random and records its colour. Without replacement, George takes out another marble at random. Complete the tree diagram. So he's got 6 red and 4 white marbles, so he has 10 marbles altogether. So for the first pick, the probability of picking a red is 6 out of 10. The probability of picking white is 4 out of 10. Now we're dealing with dependent events. What happens during the first pick will affect the probability of the second pick, because I'm taking something from the bag, but I'm not going to put it back. So if I choose a red counter to start off with, I'm only going to have 5 red counters left in the bag and 9 counters altogether. So the probability of me picking a red counter on the second pick, if I've already picked a red on the first pick, will be 5 over 9. I'll still have 4 white counters. Because I've removed one counter, I'm only going to have 9 altogether. So the probability of me picking white, if I've picked red first, will be 4 over 9. Now if I pick white first, I'm still going to have 6 red counters in my bag, but I've only got 9 altogether. If I pick white first, that means I've removed one white counter from the bag, so I only have 3 left, and I have 9 altogether. So if I pick a white first, the probability of me picking a white second will be 3 over 9. And I've now completed my tree diagram. Now, find the probability that the 2 marbles are the same colour. So I could pick red and red. So I'm going to look at the probability of red and red. So this is the AND rule, so I'm going to multiply. So red on the first pick is 6 over 10. Red on the second pick is 5 over 9. And if I multiply those together, I'm going to get 30 out of 90. And then I want the probability of white and white. So white on the first pick is 4 out of 10. And white on the second pick would be 3 over 9. And that's going to give me 12 over 90. So to get 2 marbles of the same colour, I can either pick red and red, or I can pick white and white. Now remember, when I'm doing or, I'm going to add. So I will have 30 over 90, add 12 over 90. That will give me 42 over 90. And in probability, unless you're asked to, you do not need to give your fractional answers in their simplest forms. So the probability of picking 2 marbles that are the same colour is 42 out of 90. Now, there are 8 counters in a bag. 5 of the counters are red and 3 of the counters are blue. 2 counters are taken at random from the bag. Work out the probability that 1 counter of each colour are taken. You must show your working. So I'm going to draw a tree diagram. I've only got 2 options and I'm going to pick 2 counters, so it's a pretty simple situation. So I'm either going to pick red or I'm going to pick blue. And this is my first pick. And then for my second pick, I can either pick red or blue, or red or blue. Now this is another question where we're not going to replace. So we need to remember to change our probabilities depending on what we pick first. So we've got 5 and 3, so we've got 8 altogether. So to start off with, I'm going to have a probability of 5 over 8 for picking a red counter and 3 over 8 for picking a blue counter. If I pick a red counter, I've then only got 4 red counters left and I've got 7 altogether. However, if I've picked a red counter, I still have 3 blue left and 7 altogether. If I pick a blue counter, I've still got 5 red and 7 altogether. And if I pick a blue counter, then the probability of picking a blue counter second, I've got 2 left and 7 altogether. Work out the probability that 1 counter of each colour are taken. So I can either pick red first and then blue, which would give me 5 over 8 multiplied by 3 over 7, which is going to give me 15 over 56. Or I could pick blue first and then pick a red counter. And that would give me 3 over 8 multiplied by 5 over 7, and that again would give me 15 over 56. So I can either pick red and blue, or I can pick blue and red. So the probability of picking 2 counters of a different colour will be 15 over 56, add 15 over 56, and that will give me 30 over 56. So I'm going to solve this problem using a two-way table. I've got 100 people and they study one language. They either study French, Spanish or German, and they're either in year 10 or they're in year 11. So let's have our years down the side. So year 10 and year 11. Then let's have our languages along the top. French, Spanish, German. And then let's have totals at the end. So there are 100 people altogether. So let's pop that there. 54 of the people are in year 10. The rest are in year 11. So 100 minus 54 are in year 11. So that will give me 46 people in year 11. 20 of the 29 people who study Spanish are in year 11. So 20 people in year 11 study Spanish. There are 29 people in total who study Spanish. So if I find the difference, that tells me that 9 people study Spanish in year 10. 31 people altogether study German, and 15 year 11 students study French. Now there's 46 students in year 11 altogether. 15 study French and 20 study Spanish. So that's 35 altogether. So if I find the difference between 46 and 35, that's going to give me 11 year 11s who study German. So I can now answer my question, work out the number of year 10s who study German. And that's going to be 31 take away 11, which will equal 20. So the answer to my question is 20. So here we have another question that is best answered using a two-way table. So on a particular day, 98 people visit a leisure centre. So that means then that our total is going to be 98 people. Some go to the gym, some play tennis, some play badminton, and the rest go swimming. So I've put another 4 columns along the top so that I can accommodate all of the different exercise options. 51 of the people are adults, and there are also some children. So that's why I have two columns here. I've got one for adults and one for children. If you get a question like this and you decide to use a two-way table, have a really good look at it and work out how many columns you need before you start. Okay, 51 of the people are adults. So I can then work out how many children I've got. I can do 98, take away 51, and that's going to give me 47. 21 out of the 40 going to the gym are adults. So there are 21 adults going to the gym. There are 40 people going to the gym altogether. So my children going to the gym will be 40 take away 21, which will give me 19. 19 adults and 7 children are going swimming. That's 19 and 7, so I can fill this box in. 19 add 7, so 26 people altogether are going swimming. 7 out of the 20 people playing badminton are adults. So we've got 7 adults are playing badminton. That means then that 13 children are playing badminton. Twice as many children play tennis than adults. So if we have a look, we've got 98 people altogether, and then we already know how many people go to the gym, play badminton, or go swimming. So we've got 40 add 20, which will give us 60. Add another 26 is 86. So we can work out how many people play tennis by doing 98 take away 86, and that will give us 12. Now twice as many children play tennis as adults. So children to adults is in the ratio 2 to 1. So for every 1 adult, 2 children play tennis. So if we split 12 up in the ratio 2 to 1, we can work out how many children play tennis. So 2 add 1 is 3. I'm going to divide 12 by 3 to give me 4. And my children will be 2 lots of 4, which will equal 8. So I've got 8 children and 4 adults playing tennis. So 8 children play tennis. Okay, so now we've got a Venn diagram question. So at the top, this tells us that the universal set contains the integers from 1 to 10. Set A is the multiples of 2 that are within the universal set. The intersection of A and B, so the part where the two circles cross over each other, contains the numbers 2 and 6. So I can pop those in. And the union of A and B, so everything that's in either A or B, contains 1, 2, 3, 4, 6, 8, 9 and 10. So A is the multiples of 2. I've already put 2 and 6 in my intersection. So I need to put in 4, 8 and 10. And when I'm doing this, I tend to cross them off from the universal set as I go, so that I can see quite easily what numbers I still have that need to go in. So if we have a look, I've got to put the odd numbers in from the union of A and B. Those are going to be in B. So I've already put 2, 4, 6, 8 and 10 into set A. So I'm going to put 1, 3 and 9 into set B. And then finally I've got 5 and 7 left. Those are not in set A or set B. So I'm just going to put them somewhere outside my circles, but still within my universal set. So we're now going to have a look at a Venn diagram that has 3 different sets in it, and we're going to use it to work out some probabilities, including conditional probability. So we've got this long list of people who like apple, orange, mango juice, or some combination thereof. So let's start at the bottom. We know that 90 people like all 3. So we can pop our 90 people in the place where all 3 sets intersect. Right, 93 like apple juice and mango juice. So 90 of those people like all 3. We're interested in this area here where the apple and mango intersect. So we've got 93 altogether, so we can pop another 3 people in there. 91 like orange and mango, so we've already got 90 in there, so we're going to put another 1 person in there. And then 92 like apple and orange, so we'll put 2 people in there. Now we're going into individual juices, so 96 people altogether like mango juice. We've already got 94 in the mango juice circle, so we're just going to put another 2 there. 93 like orange juice, we've already got 93 there, so we don't need to put anybody else in that orange juice circle. And 96 like apple, so we've got 90, 92, 95 that like apple juice, 96 altogether, so let's put another 1 person in there. And then to find out how many people like one of the juices, we're going to add them all together. So we've got 1 and 1 is 2, 2 and 2 is 4, and another 2 is 6, 3 is 9, 9 and 90 is 99. So we're going to have this 1 person that doesn't like apple, orange or mango juice. So we've drawn our Venn diagram. Now B, find the probability that a randomly selected person likes none of the 3 juices. So we've got 1 person that isn't in any of those sets for apple, orange or mango juice, and there are 100 people altogether, so that probability would be 1 over 100. Now find the probability that someone likes apple juice but they don't like orange juice. So we want to discount anyone that is in this area here. So this is the area, the intersection of apple and orange juice. So we're not interested in those people. We're only interested in the people that like just apple juice or that only like apple juice and mango juice. And that's going to be 4 people altogether. So the probability that people like apple juice but not orange juice is 4 out of 100. Now question C is conditional probability. So this is where we have the word given. Given that a person from the survey likes apple juice, find the probability that that person likes mango juice. So we need to see how many people altogether like apple juice. How many people are in that circle for apple juice? And we can also see up here that 96 like apple juice. So our probability is going to be a fraction of 96. Now out of those 96 people that like apple juice, how many of them like mango juice? So we're now looking at this intersecting area. And we've got 93 people that like apple juice and like mango juice. So we're going to get a probability of 93 over 96. Thank you for watching.